So our goal in this video is to gain a deep understanding on discrete random variables. But before we look at discrete random variables, let's start by looking at the random variables. What are they? So a random variable is a quantity whose value cannot be predicted with certainty before an experiment or an inquiry is undertaken. For example, the number of heads obtained when a coin is tossed 4 times, the number of prizes I win if I buy 10 tickets in a raffle, the number of cars that pass a checkpoint in a minute, the time in seconds it takes to run a 100-meter race. So a discrete random variable is a variable which can only take a countable number of values, something that you can count. Yeah. So for example, the number of heads obtained when a coin is tossed 4 times, the number of prizes I win if I buy 10 tickets in a raffle, or the number of cars that pass at a checkpoint in a minute. Yeah, so the key word here is that there are countable number of values or outcomes. So we have notation for discrete random variables. We use a capital letter X or Y to avoid confusion with the algebra type of a variable. So for example, consider a simple experiment of rolling a single unbiased dice once. We can denote the random variable by capital letter. For example, let X be the score obtained. Yeah. So the possible outcomes of these experiments are 1, 2, 3, 4, 5, and 6. Those are the faces of that dice. So this means that the variable X can take the values 1, 2, 3, 4, 5, or 6. And this can be expressed in this set notation. So, how do we calculate probabilities of discrete random variables? Let's look at this example. It will help us to gain some understanding. So consider the simple experiment of rolling a single unbiased dice once. So from the previous example, we have seen that X can take the values 1, 2, 3, 4, 5, or 6. So these outcomes can be shown in a table along with their corresponding probabilities. So we know that if you roll a single dice, which is unbiased, the probability of obtaining a 1 is 1 over 6, 2, 1 over 6, 3, 1 over 6. And the sum of all these probabilities will be equal to 1, which is very important. Yeah, because this is the sample space. Yeah, if you add all probabilities, it should be equal to 1. That makes sense. So this table, it's called the probability distribution of X. Now notice that a lowercase x is used to denote a particular possible outcome. Yeah, so this one here. So a probability distribution can be displayed in any of the following formats: in tabular form, graphical representation, or as a function. Yeah. So the tabular form is what we've just looked at in the previous uh, section. I'll explain the graphical representation, and then I'll also explain the function. Okay, so let's look at tabular form, which we've just discussed in the previous example, but you can also work it out here again. So X is a random variable, the number of heads obtained when you toss 2 coins simultaneously. So if you toss 2 coins simultaneously, what you're likely to end up with is these possible outcomes. You can end up with head and head. So you can end up with, or you can end up with head tail, tail head, and tail tail. But now here, the random variable X represents the number of heads obtained when you toss 2 coins. Yeah. So which means that X here represents the number of heads obtained. So you can have 0 heads obtained. For example, when you have tail tail, you can have 1 head obtained when you have head tail, tail head, or you can have 2 heads obtained. Yeah, so X can take the values 0 or 1 or 2. So those are the possible values of X. So A, X can take the values 0, 1, or 2. And then part B, define the probability distribution of X. So we can define this probability distribution in a table. We can represent it in simple words. We can represent this in a table. And this is very similar to what we discussed previously. So you have X can take the values 0, 1, or 2. And the corresponding probabilities is a quarter, a half, and a quarter, because you have the samples, we have 4 possible outcomes. So to obtain 0 heads, that will be tail tail, which is 1/4. To obtain head or a tail, tail or head, those are 2 possible outcomes. 2 out of 4 is a half, and then head head, that's a quarter. Okay, so we can also represent probabilities as a function or in graphical representation. This problem here would help us to gain some understanding on this. So a discrete random variable y has a probability distribution function given by f of y is equals to ky squared, where y is equals to 0, 1, 2, 3, and 4. Find the value of k and has draw a bar chart to represent f. So what we can do here is we can start by representing this in a table. So if you represent this in a table, you'll end up with something like this. So here you have y, and then this function here gives us the probabilities. Yeah, it gives us the probabilities for the values that y can take. So 0, 1, 2, 3, 4. Those are the values that y can take. Now, if you plug 0 in this function, you'll end up with 0, 1, you end up with k, 4k, 9k, and 16k. So, obviously, we know that probabilities add to 1, which means that 0 plus k plus 4k plus 9k plus 16k should be equal to 1. All probabilities add to 1. So, oops, let me just write this again. 0 plus k plus 4k plus 9k plus 16k, this should be equal to 1. Now, if we add all these guys here, we'll end up with 30k. This goes to 1. So k will be 1/30. So that means that k here is equals to 1/30. So we can add another row here for the values of f of y. And these are the specific values of y. So we have 0, plug k in place of k, that's just 1/30, 4/30, 9/30, and 16 out of 30. So the next part is to draw a bar chart to represent these probabilities. So we can graph that here. So here we'll have F. Oops. Here we'll have Y, the values that Y can take. And here we'll have F of Y, which represents the probabilities. So F of Y. All right. So I'm just gonna add something here. Multiply this by 1 over 30 so that I can end up with integers on the y-axis. Because if you look at my table, I have 1 over 30, 4 over 30, so that would be probably difficult to graph. So I've just, multiplied the y's by. That way I can use integers. So here 2, 4, 6, 8, 10, 12, 14. Oops, go beyond that, so probably up to 16. Anyway, and then here I'm gonna have 1 here. Then I'm gonna have 2 here, 3 here, and 4 there. And then I'll just draw a bar chart to represent this. For example, if you go back here, we can see that 0 is just 0, so that's fine. 1, so that will go up to 1. So that will just be up to there. Yeah. And then 2 goes up to 4. So it goes up to 4 like that. And then 3 goes up to 9. So all the way up to 9. Uh, 4 goes up to 16. And this was where 16 is somewhere here anyway, kind of an approximation. My graph was just a little bit smaller, so I just have to estimate where it lies. And then we have something like that. And that's it. Okay. So just remember one thing, that on the x-axis we have values of the random variable. So values of the random variable on the x-axis, and on the y-axis we have the probabilities. So probabilities, yeah, and we have our graph.